We are studying trigonometry. And really, trigonometry is the study of triangles, and particularly, we are interested in right-angle triangles, although in grade 11, what we start to realize is that actually all triangles can be made up as combinations of right-angle triangles. So if I give you like an acute, and you may say, oh, there's no right-angle triangle there. Well, what if I cut it in half? And then I have two right-angle triangles inside. And then you may say to me, well, what if you have an obtuse angle triangle like that? And then I'd say to you, well, what if I tell you you can have a big right angle triangle and a little right angle triangle and give you the small one here? So that we have sneaky ways of bringing other triangles into the party. But the main focus for today is just going to be on the good old-fashioned right angle triangle. And when we talk about right angle triangles, we give the sides names. So we call the side opposite the hypotenuse, we call it big H, opposite the angle or the reference angle, big O, and then opposite the other angle, or the only remaining side is A for adjacent. And most of you will have learned the acronym SOHCAHTOA to summarize the trig ratios. Now, in grade 10, we only deal with trig triangles basically in free space. We don't put them on the Cartesian plane. And you basically learn how to write out trig ratios. You learn how to solve for sides. And you also learn how to solve for angles using trig ratios. So that's what you do in grade 10. And we're going to do some warm-up questions today just to check you're okay. But the main jump from grade 10 to grade 11 for trig is going from this first drawing to the second drawing. And I would like to know, what are the main differences between the first drawing and the second drawing? So there's stuff that's the same, but there's some stuff which is a little bit different. So what do you notice that is different from drawing 1 to drawing number 2, or block 1 to block number 2? Who wants to let me know? Who's feeling like they want to share some knowledge? Siamtanda, Sange, Atlechang, Amelia, Amakle. Who feels like they can help their classmates by pointing out what is the same, what is different? What's the main difference that jumps out at you? What are these things? What is R? Why is there an R here? What is R the same as? So CM Tanda has spotted, yes, this is on the Cartesian plane. And what we notice is R, or what we call the radial arm or the radius, is the same as the hypotenuse. And then we notice that the adjacent is the same as the distance along the x-axis, and the opposite side is the same as the distance along the vertical axis. And the way I summarize this is I think of yo, like yo. So y goes with o, so I remember that goes, and then I remember a goes with x, so I just remember x, and then what's the only one left behind? It's the h goes with r. So o, so is y is for yo, and that's for x. So we have to be able to understand trigonometry in terms of o, a, and h, and also x, y, and r. Now, the reason this is so helpful is it allows us to describe triangles on the Cartesian plane. And the reason that's useful is that we can then talk about triangles that are greater than 180. And you may say to me, hold on, Mr. S, I thought triangles only go up to 180. How can you have triangles with angles bigger than 180? Well, let me show, well, let's do this. Let's pretend I'm in quadrant 1, and I'm going to draw a triangle, and that triangle is going to have an angle of 30. And I want to know what is the ratio. So this is going to be y, or it can be o if you like, depending on which thing, over here. Oh, let's leave it as y. This one over here is going to be x, and this one over here is going to be r. If I write the sine of 30, what I mean is, what is the ratio of y over r? Or if I was using this thing over here, it's the same as over h. Now put in your calculators, what do you get if you type sine of 30 in? Can someone tell me what you get? What do you get if you put in your calculators the sine of 30? We get a half, absolutely. So one way of visualizing that half is to say, well, this must be a 1, and this thing over here must be a 2, because it's y over r. Okay, but now what I want to suggest is that you can actually have a right angle triangle following the definition of trig with 210. But to visualize 210, I actually have to go 180. So let's actually do this. 0, 90, 180, 270, 360. Now, if I stop there, that's 180. But if I keep going, I will get to 210. Now, what I do in trigonometry in grade 11 is I form a new triangle, or some teachers call it the wedge. And I want to know, if you know this big blue bit is 210, what size is that red dot over there? So I'm going to try and work out now using this what the sine of 210 is. And what we're visualizing is, we know it's 180 to there. I want to know, what do I need to add? What size is that red dot there? What size is my red dot? Who can enlighten me? So Sange is quite correct. That is 30. So that is 30. So the sine of 210. Now, earlier on, when we drew our one above, we noticed that in quadrant 1, x, y, and r are positive. If I look at x, it's in the positive axis, y is positive, and r is always positive. But if I look at where x is now, where y is now, and where r is, what can you tell me about x? Now, r is always going to be positive, okay, because it's a radius. But what can you tell me about x and y? Are they going to be positive or negative based on their position in the triangle for 210? So both this x is going to be negative, so this is actually going to be negative x because of its position, and this is going to be negative y because of this quadrant. Now let's try and work out what the sine of 210 is. The triangle, well, sine of 210 is just, remember what we said earlier on, sine is just y over r. But in this case, the sine of 210 is just going to be, if I look at where it is, it's going to be minus y over r because of its position. Now type into your calculator the sine of 210, and what do you end up getting? What do you end up getting if you type in the sine of 210 in your calculator? Do you get a half, or does it change somewhat? So we know, okay, so we get, in your calculator, what you're going to notice is the sine of 210 is minus a half. And the reason it's a minus is because of that minus that's sitting over here, because it's in what we call quadrant 3. So something that we need to start to get used to with trig in grade 11 is we talk about what quadrant does the angle form in, or what quadrant does the triangle form. And so we say this quadrant here is quadrant 1. Sorry, this, I lie. I tell a lie. This is quadrant 1. This is quadrant 2. this is quadrant 3, and this is quadrant 4. And what we say with the sine of 210 is the sine of 210 falls inside quadrant 3. And it looks like if I get sine in quadrant 3, I end up with a negative value. Now, some of you will have never seen that before, but does the idea that I can explain with this drawing that the sine of 30 is a half, but the sine of 210 is minus a half, just because of the quadrant it's in. Does that make sense? Can you give me a thumbs up if you can follow that? Give me a thumbs down if you don't follow that basic idea. Okay, so basically, it's still the same 30-degree triangle. It's just that the quadrant it's in is different. That's why the value is still the same, the lengths are still the same, but it's because it's negative because it's in that quadrant. Okay, now we're going to explore that lots in the next lesson. We're going to talk about something called the cast diagram. But for today, I just want to get our kind of trig wheels back on. So, question number 1. Can you tell me what the value of the sine of theta is using the triangle above? And you just need to vote using the options A, B, C, or D. So the options are coming in thick and fast. So in this drawing, the sine of theta is just going to be O over H. So 3 over 5 or 6 over 10 or 0.6. And so the correct answer will be D. So that's just applying the idea. This is grade 10, but this idea that you can see a triangle and write down the ratio of two sides. And if you put that in your calculator, it will give you the same thing. Okay, let's move on to the next one. Can you tell me what is the value of the tan of theta using this triangle? Now I need to put some lights on. Okay, so if we look at this, tan is O over A. So the tan of theta would be O over A, which is 3 over 4, which is 0.75. And the correct option would be C. Okay, seems pretty good so far. Let's have a look at another one. So in this one, you are given 3 sides of the triangle, and you need to find the value of the cos of 60. Okay, so now what we need to make sure is we know that that's O, that is A, and that is H. So what is the cos of 60 going to be? Well, cos of 60 is A over H, which would be 1 over 2, which would give the answer of A. All right, so you have shown, if you can do those questions, that you know how to write out basic trig ratios. Now what I want to do is I want to skip. Oh, let's do this one. This is a bit harder. Can you find me the value of the sine of theta plus the cos of theta using this drawing? See if you can do that one. And then I will move on to the next type of question. Let's have a look. Sine of theta, that's O, that's H, that's A. So 7 over 25 plus 24 over 25, because that's A over H, that's O over H. But I think I'm going to have to get my calculator out here to help me, because they all look kind of the same to me. So I get 1.24, which is C. Okay, so if you can do that, you can do basic trig. Now, the next thing we need to learn how to do is we need to learn how to find unknown sides in right angle triangles. So how does this work? Well, the drawing will look a bit different. What you'll have is you'll have some unknown side that you need to find out, and you know it's a right angle triangle. You'll also be given a side that you know, and you'll be given an angle. And all you need to do is think, okay, well, that will be O, that will be H, and that will be the unknown. So how do we set up a trig equation? Well, we know what trig ratio involves the yellow and the green, or the A and the H. It's going to be cos. And so we write the cos of 31 is the same as A over 16. Now that is a basic trig equation. You have to find for me what A is and then choose the correct option from below. See if you can do that. See if you can do that. So I think you just bring the 16 from the one side to the other. And so you get 16 times cos 31 is A. So 16 times cos 31. And I get 13.71, which would be A. A will be the correct answer. Yeah, and Amakle, Sange, Amelia all agree. So we are winning at life, guys. Look at us. We are winning. All we do is win, win. Okay, no, I'm getting carried away now. So let's do another one. Let's choose this one. What is the length of side A given this triangle? And all I'm going to say to you is I'm going to highlight the sides that I think look interesting. Can you find me the length of side A? So start by writing out a little trig equation and then see if you can choose the correct option from A, B, C, or D. We're trying to find the length of the unknown side using trig. So the sine of 64 would be equal to a over 10.8. And then we know, but now we have to get our calculator out. What are you guys getting? No worries, Stephen. This is one of the realities of living in South Africa. But the good news is that we have recordings, and so you can go back and rewatch that. A lot of the times lately, recordings have been out the same night or by the next morning. So just have a look at those. But it's good to have you with us, Stephen. Okay, I get 9.7. Yep, so I get C. Awesome. Okay, so we know what we're doing with this. This is good. Now, the last thing that we need to be comfortable with from grade 10 trig is finding unknown angles in right triangles. So how does this change? Well, instead of giving us an unknown side, they give us one side and they give us another side. And we have to build a little trig equation. So to build a trig equation, we need to know who's who in the neighborhood. So that's O and that's H. Now, what trig ratio involves O and H? It's sine. And so now we have the sine of x is equal to 7 over 10. But we've got a new problem. The x is locked away inside the trig ratio. Now, the way we unlock it is by using what's called the inverse trig function. And in your calculator, what it basically does is it says, look, what undoes sine? It's inverse sine or arc sine. And so, sorry, it's a bit messy, but basically what you get is you type into your calculator, what is inverse sine of 7 over 10? So I want you to go into your calculator now and go shift sine 7 over 10, and then I want you to choose the option from the things below that will help us get what x is. And then put your answer in the chat. So make sure now you must use the shift key or the inverse sine key. So I go shift sine fraction button 7 over 10. And what do we get? What are you guys getting as your answer? There's two ones that are quite close together. What are people getting for this angle x here? I get 44.427. Now, even though this is close, it's not that, it's not that, and I would choose B as my angle. Can I have a thumbs up if you followed how to find an angle now, and a thumbs down if you didn't follow me? I want to do one more before our break, and then we're going to take a break. But I just want to check you all know how to find an angle. So give me a thumbs up if you followed how I found that angle and how it's a little bit different than finding the length of a side. They both involve trig equations, but you need to lay it out slightly differently. Okay, let's do one more before we head off on our halftime break. I want to know, can you find me the size of angle X that's hanging up upstairs over here? I know it's a little bit unclear. And then on this side, I have a, oh, that's a bit messy. Hey, let's rather just get rid of that. There's an 8 hanging out over here on this side, and there's a 10 hanging out over here. What do you think the size of this angle X over here is going to be? What do you think the size of this angle X is going to be? So let's see what, if this is, that's going to be O, that's going to be A, that's going to be H. The ones that are involved are O and H. So it means the trig equation that I'm going to write is going to be the sine of x, and that's the angle x, is equal to, how does that work? Well, if that's O, I've written it the wrong way around. Goodness gracious, look at that. I had a moment. That should be H and that should be A. The reason I knew I'd made a mistake is that sine, it couldn't be greater than 1. So in that case, let's just make sure I'm doing the right thing. So we now have O and A, in which case, what trig ratio involves O and A? It's going to be tan, and the tan of x is going to be 10 over 8. So if I go to my calculator now and I go shift tan and I go 10 over 8, I am getting 51.34, which gives me option C as my correct answer. Give me a thumbs up if you follow my logic. So let's just go back one last time and check that we did, because I made a bit of a boo-boo there at the beginning. That's the O because it's opposite this. This H is opposite the right angle, and that must be A. What trig ratio involves O and A? It's tan. What's the reference angle? It's X, and it's going to be 10 over 8. Now I use inverse tan or arctan to get the X out of jail, and I get 51.34. Okay. Everyone, we have done more than a half an hour's work, so it's time to unwind and take care of our brains before we start to fall asleep here from too much hard work. So I want everyone's cameras on, and I want to see you on your feet. I want you taking care of your brain, and I want you to stand up with me. And we're just going to turn our cameras on, and we're going to take some nice deep breaths. So felt incredible. Feel the oxygen running through my brain, making me smarter by the moment. Breathe in. Feel alive, people. I feel alive. Okay, now my body is feeling tight. I've been sitting in a chair. I want to loosen up. So I'm just going to shake my arms out a bit. Shake on this side. Oh, nice and flappy, nice and loose. Shake out your legs. Shake out the other leg. And then I want you to put your arms out. And I want you to just roll them in small circles. Guys, you are missing out. If you're sitting on your bed or if you're sitting somewhere, your body is just saying, please take care of me. Okay, go the other way. Oh, this feels good. Okay, then roll the shoulders back. Roll them back. Roll them forward. Because your shoulders can sometimes get a bit tight. That's awesome. Shake out the arms again. Shake it out. Shake out the legs. Okay, arms out. Slight rotation. Just a slight rotation from the hips. Just very gently. And then as you relax, your body will naturally go further. Okay. All right, then, just to get some blood pumping through our body, we need to get our heart pumping. We're going to do jumping jacks, and we're going to do 15. And this is a jumping jack in case you've never seen one. So we just go in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And now my body says, thank you for taking the time to make me feel happy. And then what I want to do is I want to share today's little brain break. So let me just do that, if I can find it. go. So today's brain break is what we call Maths 24. And so you have to make the number 24 using 4 numbers on the card. You may only use each number once, and you may only use each number with the main operations plus, minus, times, divide, and brackets. So can anybody get me to 24 using the red card or the blue card? I leave that to you, my students. Okay. So I want to suggest that maybe 8 minus 5 could give me 3 would be a nice way to start. So if I use 8 minus 5 and I get 3, I've still got to use these 2 numbers to get me to 24. Who has an idea of how we could do that? There is much glory on the line, ladies and gentlemen. Claim it. It is yours. Siamtanda has grabbed it. Siamtanda suggested that I've got 3, and if I go 3 times 8 times 1, I have 24. And Siamtanda, you have Maths 24 points in the bag. Does anybody want to have a crack at doing the blue one before we go back to our trigonometry? Ooh, we have a bit of a Maths 24 ninja in our midst. So 8 times 2 is 16. And then plus 7 plus 1 does indeed give us 24, Siamtanda. Thank you very much. All right, so we are going to head back to the second half of the lesson now, but that was very nice. Okay, so let's just do one more of these finding the angle questions. So what is the size of angle X? You need to build a little trig equation, and you need to tell me then which of the 4 options you think is correct. Which of those 4 options do you think is that angle there? So that is O, that's H, that's A. Can you build a trig equation? The way it would look on your calculator would be like that. So you go shift cos 5 over 8, and you get 51,32, in which case you would get A as the correct answer. All right, I feel like you guys know how to write out trig ratios, how to find angles, how to find sides. Let's go and have a look at this rather interesting old exam question. So it says, MNP is a right-angled triangle, and it is indeed a right-angled triangle. I can see it. Inside this are 2 angles. There's an alpha, which is hanging out over there, and there is a beta, which is hanging out over here. Can you find me I want you guys to find me the sine of alpha, and I want you to find, in fact, let me keep it in the colors that we're using here. So I want you to find me the sine of alpha, and I want you to find me the sine of beta using just this drawing. So, and then once you've got it, oh, wait, what else? Write down the ratios. No, let me put these values in, sorry. It says MP is 13. So MP is 13. NP is 5. How would we find this one over here? Okay, because of time, I'm actually going to save us some time. I'm going to say that this is 12. I could have used it by trig or by Pythagoras. Now, using what you see here, can you tell me what is the sine of alpha in pink? What is the sine of beta in blue? And I want you to put it in the chat for me. What is the sine of alpha in pink? We'll call that A. What is the sine of beta? That's B. I want you to tell me in the chat there. So the sine of alpha, I just look what's opposite that. It's going to be 12, and then the H is 13. So it's 12 over 13. I agree. What about the sine of beta? What is the sine of beta going to be? Well, now there's a different angle as the reference angle. So opposite that is 5. And that's still going to be over H, which is 13. Now, this is a bit harder because there's funny letters and the triangle looks a bit different. But let's carry on. I want to know what is the tan of beta and what is the cos of alpha using this triangle that you see here. So see, what is the tan of beta and what is the cos of alpha? And remember, there's no calculators per se. We're reading off these ratios from the triangle. So let's have a look at the tan of beta. So the tan of beta, I actually need to know where O is. So that would be O in reference to B, and A would be over here. So the tan of beta is actually going to be 5 over 12. So O over A. Now, what about the cos of alpha? What is the cos of alpha going to be? Well, now I have to make sure my O and A are written in different places because the reference angle, so this is O because it's opposite A. That is always H, and this is going to be A. Now, for the cos of alpha, I want A over H. So I actually want 5 over 13. Now, what's rather interesting, I mean, it's just interesting, is to notice that the sine of beta and the cos of alpha are the same thing. And there's something to that, which we will explore later. Now, I just wanted to show you a slightly visually confusing triangle. Give me a thumbs up if you could navigate your way through that with putting O's and A's in different places. Give me a thumbs down if you feel a bit lost. Okay, that's good news. It means that you're getting stronger here. Okay, then let me move now. We've done stuff like that. We've done stuff like that. We're fine. We don't need to do this. Ooh, this gets a bit interesting. Okay, now this is a bit of a preview of the next lesson, but it's too much fun to not let go yet. What type of graph is this graph over here? Now, oh my goodness, Mr. S, where did this come from? But maybe you saw it in grade 10. What type of graph is this? This is the sine graph. Yes, it is. The sine graph starts at 0 and it goes up to 1 at 90, then down to 0, then down to -1, and then up like this. And so that would be 90, 180, 270, 360. And the highest, oh wait, this should have gone lower, hey? Because this should have gone down to there. So the highest point it gets to is 1, the lowest point it gets to is -1. Now, this begs an interesting question. In the next lesson, we are going to talk about something called the cast diagram, where angles can be bigger. So earlier in the lesson, we said, like, what is the value of the sine of 210? And I said to you, the way to visualize 210, the angle, is to draw 180, go an extra 30, and then draw this wedge-like part over here. And that angle of the 210 makes an angle with 30. Now, this information, this cast diagram, can be put on a graph. So if you look at this question, it says, for values between 0 and 360, which value is equal to the sine of 30? Now, what value is the sine of 30? Well, let's go and find 30. So that's 60. So I guess that's 90. So 30 is going to be over here. So there's 30. And if I go up to 30, this graph is saying the sine of 30 is a half. Now, if you look at your graph and you know that that line is a half, what is the next, what is going to be, of these 4 options, which one is equal to the sine of 30? And I want you to vote in the chat. So if you look at this half and you extend it further, the next time it cuts the graph is over here. And if we look down, you'll notice it's halfway between 120 and 180. And so it's at 150. And if you type in your calculator, you will see the sine of 150 is in fact a half, which is good news for you, me, and everyone else. Okay, well, this is kind of fun. So let's play this game a little bit. If I said to you, I'm going to change the question now, and I'm going to ask you which value is equal to the sine of 330. Can you tell me a value out of these first 4, 1, 2, 3, 4, that is equivalent to the sine of 330 if you just look at this graph here? So what value, A, B, C, or D, is going to be equivalent to the sine of 330? So first, let me find where 330 is. So it's halfway. So there's 330. And what value is in line with the sine of 330? Well, it's in line with minus a half. And that's what the sine of 330 is. It's minus a half. But if I look at the drawing, what else is equal to minus a half? It does appear like it's halfway between 180 and 240. And so that is 210. So you will notice that the sine of 330 is actually equal to the same as the sine of 210. They are both minus a half. Now, this is an important idea for grade 11 trig, is that sine is a periodic function. It repeats itself. And it repeats itself every 360 degrees. You can see it goes up, down, down, up. And so when we have solutions to trig equations, we don't just have one solution, we have multiple solutions. And this drawing shows you a little bit why there's more than one answer. So if I said to you, what is the value of x such that the sine of x equals a half? Not only would the answer be 30, the answer could also be 150. And so tonight, I just want to make sure that you guys understand that trig equations can have more than one solution because of the repetitive nature of trig functions or the periodic functions. Give me a thumbs up if the graph helped you see why both x is 30 and x is 150 would be an answer, a correct answer. Give me a thumbs down if you didn't follow it. Okay, I'll just give you a moment to let me know. That's good. And we're going to explore that more in the next lesson. But let's just finish. Oh, look at these lovely functions. Okay, we'll get to that in the next lesson. Okay, so the basic trig functions, we just looked at the graph of y equals sine x. So you can see what that looks like. And then you also need to know what the graph of cos x looks like. And you'll notice that cos is just a bit different. It starts on 1, and then it goes down to 0, down to -1, and up and up. Now let's use a bit of, okay, let's do this. I'm going to say that this is in line with 0. Actually, let's make it to scale. Let's try and solve this. If it was halfway, and I drew a line like this, I'm going to say this is 0.5. Can anybody tell me what angle that's going to be? So I'm saying it's the cos graph, so I'm going to set up the equation cos of x equals a half. Now, I want to know what is the angle here, and I want you to use some trig. You don't even have to look at the graph. You use your calculators. Can you tell me what value of x gives me cos of x to be a half? Can you solve that for me? Let me know in the chat. Now, if we go back to earlier in the lesson, we have to use inverse cos. So inverse cos of a half to get what x is. So x is, what are we getting for x? Siamtanda and Sange have given me an answer. What are you guys, anybody else? I think that they are correct, that you get 60 degrees. All right, so if you put in your calculators, just do this, type the cos of 60, and do you get a half? Yes or no? So I get the cos of 60 as a half. Now, using this drawing, I want to know what is the other value of x that when I put it into cos, I get a half. What is the other value of x between 0 and 360 that when I put it into the equation cos of x is a half, it makes it true? So you've got the one solution. I want to know what is the other solution, and I think it is sitting over here. Who feels like they can tell me? You can even try it on your calculator. What is the other answer for this trig equation? Now, I haven't taught this to you yet, and you probably haven't been taught it at school, but I just want you to use common sense. What does it look like? It doesn't look like it's halfway. And you can try this in your calculator, but you will notice that this value is 300. So if you put in your calculator the cos of 300, you will notice that it is also equal to a half. And you can visually see it on the graph. Now, what are we going to do in the next lesson? In the next lesson, we are going to combine like the cast diagram. So basically triangles that can occur on the Cartesian plane with right angles and things like that. And we're going to combine it with our view of trig graphs to help us make sense of what does it mean when I say the sine of 300? What does it mean if I say the tan of 210? We're going to give you more pictures and ideas to go with that. Today was just kind of getting yourself back into trig and getting the basic ideas going.